This year, we celebrate 70 years of knowledge and innovation. I'm your Stamicarbon storyteller, and will guide you through an exciting story that begins here. It started with this document. In 1947, DSM found Stamicarbon. Stami, a contraction of state mines and carbon. One of the first companies fully dedicated to technology licensing. And Stamicarbon issued the first urea licenses for plants in Belgium and South Africa. In the 60s, it was an exhilarating era, with the Beatles, Rolling Stones, hippies and flower power. During this time, chemicals and chemical technologies were on the rise. That was where the real business was. DSM decided to develop its own urea process, incorporating a crucial innovation: adding oxygen in the synthesis section to suppress corrosion of the plant equipment. But let's fast forward to 1965 for the next innovation. Stamicarbon designed its CO2 stripping urea process that simplified the urea plant and improved its economics. Today, all modern urea processes are based on this principle. In 1978, Stamicarbon started with computer-based plant simulator TISFlow. Revolutionary at that time.
Technology of TISFlow and the way to solve mass and heat balances, which is always mass and heat balances, it's the heart of technology. That's where every projects in the technical sense start with, to predict plant by behavior later on. So that's, in my opinion, the main innovation within Stamicarbon.
And it goes on. Bangladesh. A new urea plant had to be designed. Only a tiny problem. There was an airport next to the plant. Nothing was allowed higher than 40 meters. However, the height of the traditional plant was over 60 meters. So, no problem. What comes up also can come down. Why don't we put the synthesis section horizontally instead of vertically? Might be more efficient too. And the innovation continues.
A molecular dating site where 2.4 molecules are desperately looking for one molecule of CO2. Everything is already there, all candidates are already laying there in the liquid. This is basically why pool condensation is so much better than surface condensation.
And so a new innovation was born. In 1994, the pool reactor was developed by placing the carbamate condenser and the synthesis reactor in a single horizontal vessel. In doing so, reducing both the height and the cost of the plant. In 1995, the Urea 2000 Plus process design optimized the urea process for plants with up to 2000 plus ton per day. In answer to the growing demand for a safer and more effective urea process, Stamicarbon, together with Sandvik, developed Saphirex in the early 90s. An affordable duplex stainless steel for urea. Saphirex withstands corrosion without oxygen, and so eliminates the risk of hydrogen explosions. Ever since its introduction, it became the standard corrosion-resistant material in urea equipment.
It was for me the invention of Saphirex, as I mentioned. That was the pool reactor, and that was the mega plant, the pool condenser. Yeah, that was the breakthrough for the Stamicarbon technology.
And it goes on. In 2001, the mega plant concept made urea plants with a production of 5,000 to 6,000 tons per day possible. In 2002, developed their fluidized bed granulation technology, with very low dust emissions, energy and formaldehyde requirements. Radar level measurement for non-radioactive monitoring of liquid levels in synthesis section vessels were made possible in 2005. 2009 is marked as an historical year. Stamicarbon was sold to Mare Tecnimont, an Italian engineering and contracting group.
We had very good engineers, for innovation, but we cannot do everything ourselves. I think positive thing was that we were looking into partners that were already in the business of big contracts and big plants. Meyer Technomont was very much interested. At the same time, many people predicted DSM, you were selling the golden apple, which proved to be true because I think the investment of Technomont was paid back already, of Meyer Technomont was paid back within a few years.
And it goes on. In 2010, the first commercial license for the launch melt compact design was a sole design with a height of only 40 meters and with less equipment. Over the years, the environment became more important, so it was more than logical that in 2012, Stamicarbon introduced its thermal treatment design, a unique proprietary solution to design urea melt plants with zero ammonia emission in an environmental and cost-friendly way. In 2015, the launch melt low-energy concepts were introduced. No need to explain that we adapted again our technologies to the needs of the changing world. Let's go to 2040. The agricultural landscape has changed drastically, with vertical cultivation and more efficient water usage and farming methods. How will our future look like? See you on Mars.
I think the main difference is the people.
But we are the most dedicated people. We have a high standard of service.
We're now a very international oriented company with employees coming from all over the world. The openness with which people can communicate over such things, clients directly profit from.
And that is the big advantage of Stamicarbon. It always gives you the possibility to improve yourself and the process.
Our business was licensing, so we could give all the attention, with all the 49 and I think nowadays 160 people, to the process of licensing. Innovation, high quality and high service. And the relations.
Looking into the future, I'm quite optimistic. The growth of urea as a fertilizer is slightly more than the GDP and the growth of the population. And this ensures our new and future business.